When exposed to a naked flame, hydrogen can be extremely dangerous. But hydrogen's potential as a clean, renewable source of energy is also extremely attractive, and laboratories around the world are looking for ways to store and exploit it safely. Scientists at the EPFL Institute in Lausanne believe they've found one. These are microscopic hydrogen bubbles being produced by an unexpected source, iron oxide, commonly known as rust. The researchers believe molecular hydrogen extraction using iron oxide, sunlight and water presents an inexpensive, eco-friendly solution for storing renewable energy. Ludmila Steyer is one of the EPFL team.
Right now it's actually just the air taking the solution of iron acetoacetonite, and combined with the heat it's transformed to iron oxide.
The iron oxide is more highly developed than that found on a rusting car. It's nanostructured, enhanced with silicon oxide and covered with a nanometer thin layer of aluminium oxide and cobalt oxide. A layer of di and titanium dioxide lets electrons transferred by the oxide gain sufficient energy to extract molecular hydrogen. The team, led by Professor Kevin Sivula, is working on a variety of methods of extraction.
We can take nanoparticles of iron oxide and disperse them in a liquid, making something like a paint, which we can just paint onto our substrates, leaving a nanostructured iron oxide behind. In another, more efficient way, we can deposit iron oxide by essentially smoking it onto the substrate. By making very small particles of iron oxide in a gas phase and having them hit the substrate, we can make high surface area iron oxide, which is precisely doped with the right amount of silicon that we need to have a high performance electrode.
Producing the chemical is done by splitting water into its atomistic components, oxygen and hydrogen. The team says it's a technique that can be used anywhere in the world, solving one of the biggest problems caused by transporting hydrogen: its inherent volatility. PhD student Moran Cornu believes the painting method could yield the best results.
We moved into that ink process that allows us much better control for the morphology, the nanostructuring of the electrodes, and also can be translated to a roll-to-roll process, a large-scale deposition.
The team believe the system could vastly increase the potential of storing solar energy worldwide.
Iron oxide potentially is extremely inexpensive, so it could compete even at a lower efficiency. That said, where our efficiency at being only around 1 to 2% does need to get up a little bit higher before these devices could be commercial. So to do that, we're really digging deep into the science of both the nanostructure of the iron oxide, but also the electrochemical processes that are occurring in the material in order to first determine what the loss processes are and then to make them better.
The team is excited about the potential of their research. They say hydrogen power is certain to make an impact in the future.